Um, hello. Hello, my name is Ben, and I'm going to present fast and fresh disposable cubes and how this is reviving a decade-old issue. This table of...
Muted or something?
No, it is working. Please say something.
Hi.
Yes, it's working.
Okay.
Test. Okay.
Maybe you're speaking to... You have to speak up silently.
Okay. Hi, my name is Ben.
Yeah.
I'm going to present fast and fresh disposable cubes and how this is reviving a decade-old issue and how things in cubes can take time, but they happen. Yeah. Table of contents. I'm going to start explaining a bit about me, why the disposable usage is low, how preloaded disposables can help, some demo and benchmark at the end, acknowledgements, contact, blah, blah, blah. I'm a FOSS maintainer and contributor. I've done some things for cubes. The management stuff was more during this task of preloaded disposables, which I also interacted with a bit of GUI applications. A bit of surprise for me. I did some things for QOSS, such as the Vim QOSS plugin and qubes policy lint and qubes policy editor. And I did an orchestration tool called QOSS to manage your cubes with salt. I've contributed to other projects also. Disposables. They are pristine cubes, and they aim to provide a pristine environment, of course, which is clean and more secure than running code that you don't trust, or opening an application you don't trust on the same cube as your client, as the receiver. And they also provide a consistent environment, so when you want to test different things with always fresh cubes, you always have the same environment. There are two types of disposables, named and unnamed disposables. The preloaded disposables will utilize the unnamed disposables only. And the difference between them is that unnamed disposables, they are shut off when you close the first application that you open in them, when the color ceases. And with named disposables, they only shut down at will, at your will. And there are some things of why getting a fresh disposable is slow. Mostly cube startup, the second item. Other things contribute to it, but it's mostly cube startup. So we want to speed this first. Sorry for the slides, not fitting very well here with this resolution. But what people do to circumvent normally is they open files in non-fresh disposables, like named disposables that are already running and have run a lot of code or a lot of file conversion. But this is a dirty tactic, or they do other tasks in the meantime, as Marta has explained before. This context switching with people losing focus can make you more insecure, because you're not going to be connected with your computer anymore. You're going to do something else in the meantime. You're going to open another application. And this was supposed to be a slide that would fit. No, not my problem, because people, they think they can multitask. But there's a limit of how many tasks you can multitask if you think you can do that. In 2015, at the end, a user called qubes user literally opens an issue to have faster disposable cubes. And Marek said, too late for the epoch, 3.1, but maybe in 4.0, which took a lot of time. 4.0, I think, was 2020 or 2019, but yeah. Then I thought I could do it fast, in like 2 weeks also. It did not happen in 2 weeks, and I'm still fixing issues to this day, but it's mostly complete. That's what I can say. So some requirements is that the usage is almost instant. It's never going to be 0 milliseconds, but we want to get close to a cube that's already running connection. Like instead of requesting a disposable, the same time that would take to request another VM that's already running. And memory footprint low, security preserved, it doesn't change the security aspect. Transparency, color preserved, like you don't need to change your scripts, your way of usage. You're going to utilize preloaded disposables transparently. There were some alternatives considered, such as dump file that was used in 3.2. and still documented in the disposable implementation file. But there were multiple issues that I got from the Marek's talk last year. So unreliable. And ZenVM forking, the problem is insecure because it shares too much information like random seeds with a cube with multiple cubes, and that's not nice. And it does not really work on long-running sessions. And Q, which is what Preloaded architecture uses, but it comes with its own problems because the previous options don't have a queue, the cube is not running. But now that the cube is running, we have to hide it from a lot of GUI applications. We had to make a lot of patches for them to be invisible for the user until they need to be seen. So you don't have clobbering around your system. And it also allocates memory for cubes in Q. So we did reach a quite good point, which is it gets to the kind of min memory of the cube. So if you have a cube that's set to start with 400 megabytes, it will be up to that when the cube is paused. Because when the cube is paused, it cannot share memory of other cubes in the system. And pause, I'm going to explain the next slides. So qubes has already some existing resources to help with that. I built upon it. And we are going to see the design and some code samples, but not much code this time. The server part, it has qubes-D and qmemn. Qmemn is the memory manager. And the client side has the QVM tools, such as QVM run. It also has QVM start daemon that's controlling the audio and daemon. Not the server, but it's another kind of server. And this connection allows for you to filter, for example, what type of connections can the client make to the server with QRexec policy in case the client is not on DOM 0, because on DOM 0, QRexec policy evaluates always through and allow. qubes-D is also event-driven. So that's mostly what was used for Preloaded disposables. We got some event that something's happening on the system, and we act upon it. In this example, it is a kind of pseudocode that I minimized to fit the slides. But in the qubes-VM class, you have a start function. And then you have a handler with a decoration for it that you declare with qubes events handler decoration. And then you can do anything. In this example, I'm just logging the event that was received and the cube name. The lifecycle design, which is first Q, the cube. It's added to a list on the disposable template as a feature. Then it becomes hidden from most GUI applications using the internal feature. And this happens using the previous example of events that when the internal feature is set, it hides from the GUI applications from being able to, for you to find, not if the application is already open. Then it passes through the startup phase where it waits for the cubes to be fully operational. And when it concludes, it pauses the cube. It pauses the cube to not waste CPU cycles. The memory is allocated there. And yeah, because also pauses the cube because it fires an event that the cube was unpaused. If we know the cube was unpaused, we know the cube was used. And if the cube was used, we marked it not preloaded anymore to not reuse the same cube. So it like burns this cube. Request. The cube is removed from the list. And request can happen at the same time as startup. So if it happens at this time, the pause will not happen, and then the unpause will not happen also. After the request, the preloaded disposable is marked unpaused, marked as used, becomes visible in GUI applications, and it starts preloading another cube. For now, it preloads right after the cube is marked as used, asynchronously in a future. But we have some improvements and think that maybe on case-to-case basis, it can be delayed by some seconds to not alter some things that I will show later on the benchmarks. Just a moment. The white part is the old cube disposable design, and the green part what was added to Preloaded disposables. So this corporation's cube startup, QOSS agent startup stays during the QE phase, which is where the cube is being preloaded. Was added, wait for the system to be fully operational, and pause. Pause can take some time, but if you're gonna pause, you're not gonna request the cube right on. Like the pause takes some time because it tries to retrieve memory from the cube. So it takes some time, yeah, because it depends on collaboration. But the important part is what you actually notice, which is the request part. On pause, which is quite fast, only happens if paused. And GUI agent startup if you're using a graphical application. The GUI agent startup has some issues. It happens, but it is delayed by 1-2 seconds, and we want to cut that, and I'll explain later on the slides how that can be done. It also depends on the service. So, of course, for disposable usage, it's already depend on QOSS, but now it has these new services that are added to all the templates in the Qubes Core Agent Linux. And Qubes Windows tools will have this in the future. I don't know when, but I hope it will work with Windows disposables also. If you're tired right now, I want you actually to focus more on this slide, which is 2 important features. Preloaded VM Max. It is a global and local feature. Global means you can set it on DOM 0, and it applies to the global default disp VM. And local meaning you can also set on disposable template, which applies only to that disposable template. And this feature does you set the number that you want of preloaded disposables for that disposable template to have at maximum. It will not always have that number, but at maximum it will be this number. The second feature is preloaded VM threshold, which is a global feature set on DOM 0, and it's in megabytes. And you specify how much megabytes you want to have left on the system of free memory. For example, if you have, if you're using 15 gigabytes of memory and you set a value of threshold, and there's a preload that wants to be queued, it will not be queued. It will reject. So it avoids a bit of memory exhaustion. So a bit of some workflows that you can do. For example, for the default DVM, I would use the global feature because it's not a specialized disposable template. So you're using for browsing, file conversion, when you're getting started into cubes. For the default management DVM, it is not actually now working with Ansible or Salt because it uses named disposables, and there are some designs that need to be done for it to work with unnamed disposables. But with console, the admin console, QVM console, this VM, you got a Zen console in DOM 0, it works. And for example, for the Qubes Builder DVM, where you'd use the Qubes executor, you'd also set the local feature. There's an auto start service, so it only starts the first preloaded disposables after boot, after the normal auto-started cubes have already started, and only if the skip auto-start kernel flag is not set. But some people, they don't like the preloaded disposables from starting at boot. So okay, you can disable the service, but don't refresh it, because don't restart it, because it's actually a refresh of preloaded disposables. It will not cause problem, but it's unnecessary. Just start the service once if you don't want preloaded disposables to start at boot. And gaps can happen momentarily, and there are some cases, such as example explained before, insufficient memory, failure to preload because for any reason, actually, outdated volumes, which happens on template updates or disposable templates, when they shut down, means that there's an outdated volume, and we always want the fresh disposable to be fresh, so they always need to have the latest version of the volumes. Or, for example, qubesd, the daemon controlling the event fire and starting the cubes, it's interrupted, so it will fail. It will remove the preloaded disposable that were not complete because you don't know actually their state, and it will be preloaded again in the future. Yeah, just a bit of feedback for, yeah. Users, they exist. Every further 3 user is basically using it if you have more than 15 gigabytes of memory. So that with 15 you have 1, with 32 you have 2, but that's just the default. It does not mean that's the maximum you can use. There are some more users in the future. Secret Drop and Danger Zone, they already have open issues about that. I'm waiting for them to reply some things. Let's see if they evolve on that, but there's not much they can do, but there's different ways they can leverage. It's not fitting the slides here because of time, but I have on the talk on the Git repository some extra markdown file explaining how to leverage more preloaded disposables. Now it's demo time. I hope I have time left.
No worries.
No worries, okay. The Q domains is actually open down here.
Oh no.
But yeah, I'm not gonna.
But you can see the domains widget.
Mm-hmm. You can see the domains widget.
Yeah, it is on the screen. Yeah.
It's here.
Yes.
No, but I opened it. It's not appearing. But anyway.
Oh, it's below.
Yeah, it's below. Yeah, okay. Sorry, cubes. I'm gonna explain the global version first. Just a moment. So I have some kind of Q domains for the terminal. These are the cubes that are running. It will fail some time because it's not very dynamic, but okay. Cubes global config. I don't have any disposables running there. This is the default. 1000, it's adaptive to your amount of system memory once during the installer, but you can set any time the threshold. You have to enable it. I'll just use one as an example. There should be a notification that the cube is start. It's here. It's right on top. It's there. I cannot show right now. Sorry for the resolution.
This cube name stats is showing preloaded.
Yeah, here.
Yeah.
So there's this cube that was preloaded. And the P means it's paused and it's using 400 megabytes right now of memory. And if I open the tuner, for example, the file manager, and open in disposable, view in disposable, it's not clickable because of the.
Sorry.
It is opening, and it opened quite fast, I'd say. Thanks. And let me see this is the application menu. So this is another way that you can open preloaded disposables. Using the apps tab, you open the XFCE terminal. You can see this is a descendant of default DVM, which is the cube that's running right now here with the graph open. But you cannot see the other cube that's also running, which is the 2698. So it's hidden from GUI applications. It's also hidden by default from the cube manager. And just as an example, okay. You can set it. All you can do on the command line. No, I'm not gonna show. Sorry, it's not gonna work this time. Okay, then.
Different from scaling. Yes.
QOSS config file manager context menu. So okay, I showed how it works, and it was quite fast. And even though this is a good machine, it is not as fast on this machine. I could, yeah. I could remove. The cube is not on here anymore. The total doesn't work. I did this issue. Okay, so the cube, there's no cube preloaded anymore, no disposable preloaded. And now I'm gonna show like how much time it normally takes that I should have shown before. Now we're waiting.
Let's go for a coffee.
Yeah, we can do something else. And this is quite a fast machine, so it's still slow anyway. Okay, now I will proceed to benchmarking and scaling. We did a lot of benchmarking. There's more to be done, if I'm allowed also. Sequential and concurrent calls originating from DOM0 or from qube, GUI applications versus headless applications, normal versus preloaded, and on different templates. There's not going to be enough time for every graph, but I'm going to focus on Fedora 42 XFC because it's the default on qubes for some time. Okay, so if we look at this graph, which only accounts for the total time of a call using the API, which is a raw call API, QVM run uses the API, but I did just some lines just to get what's necessary. And it doesn't not seem so fast, like 3 seconds and just 2.5 times fast. And with GUI, you can see it's a bit longer. But that's not the number we saw before, because it felt so much faster. This is only the execution time, which is extracted from the last graph, which for the no GUI applications, we reached like 700 milliseconds, which is quite decent. And it was 9 times faster than normal disposable cubes. With GUI applications, it takes some time, very noticeable, like more than 2 seconds, 2.5 seconds, because the GUI only starts after the preloaded disposable is marked as used, because there's an invisible mode in the GUI, but it doesn't work if when the cube is already running. The problem is if the cube has, for example, an application that would auto-start, or such as Network Manager, it would be unclickable, and the user would not understand because the cube is paused. So they can't interact with it. And now it's a compilation of what you can see, and the gray part is the cleanup phase, which does not normally take more than the disposable startup, but in this case, because the execution is so fast, the cleanup takes more time. The cleanup of the preloaded disposables takes a long time because it is preloading another disposable in the meantime. So I tested without preloading disposable right after it was used, and it reduced in 1 second, getting close to the normal disposable usage. And this is some comparison of line by iteration using no disposables right on top. 3, 4, and 5 on this machine, which is a 32 gigabytes machine, Intel Ultra 7. It has a PX 700 SSD. And we can see that it was very decent under sub-second. And we can see, for example, the spikes on the 3.4 on the 10th iteration of the 3D preloaded disposables is because there was no preloaded disposable anymore. So we had to wait for the disposable to start. But in any case, in any situation, it is still better than having no preloaded disposables, because it would be much slower. This is the total time per iteration. Sorry, before it was the execution time only. This is the total time per iteration. The total time, remember that it adds the cleanup phase. So the cleanup, it is what it's added here compared to the previous graph. There were some variations, like it reached 4 seconds, but the mean for preloaded disposables, which is the default that we're using, it is 3 seconds in total for a call. But you don't notice the 3 seconds, you notice that less than that. And that's it for the benchmarks. Some considerations. Pristine disposable cubes, they're more secure. Pristine disposable cubes are more secure. Preloaded disposables lower the bar for entrance. It is scalable. You can set as many preloaded disposables as you want. The GUI only allows you to set 50, but if you have a server, you can go crazy. Usage speed is UX, and better UX is better security. I want to thank the ITL and Keeps team. It was a very nice project, and I hope to continue now that I'm in the team. And the Keeps community, because a lot of bug reports helped. My contact information, PGP key, and some references to issues that I mentioned. And thoughts, questions?
Yeah, thanks. That's an amazing improvement. Thanks for that. I'm not sure if my question really applies to you or your work, but I saw that you wait for an event like fully functional or fully started. How is that evaluated? I think that's quite difficult because you never know when the last system, the initialization is finished or any application has fully started.
You mean this one? Yeah, so it uses basic systemctl is system running. So it checks that because if the system is fully operational, it will either report degraded or valid, something like that. So every service has finished, has concluded, either failed or started successfully.
So actually that's fully solved. I just see it on Windows all the time. You can log in, but you can't really use the system already. So.
Yeah, you can interact directly with the system like quite fast.
So this is actually some systemd state that you can question, or systemd notifies you.
Yeah, it's a systemd notifies. Yes,
okay. Yeah,
that's what I mean.
Whilst I'm not suggesting you should immediately move to it, you said earlier that Zen VM forking was insecure. Can you expand on that a bit, please?
Yes, so I based my talk on Marex, but also a bit of the knowledge that I got. It is that it is sharing like seeds from the forked cube with the descendant.
So there is an extension for all virtual machine types. It's called the VM generation ID. And that exists specifically to be a notification to the VM to say that it's been copied or it's been reverted to snapshot or something like that. It was originally put in for Windows to do checks on AD controllers as to whether their state of the world is valid or not. I've forgotten his name, the guy that did WireGuard in Linux, he put support for Linux to do this as well. So you can now write 128 bytes into memory, tell Linux that it's a copy of itself, and it will reseed everything in the system, including into the user space VDSO for accelerated.
That is nice to know that represented.
Yeah, I think that's been working since Linux 6.14, something like that.
Okay, so pretty recent.
Yeah, it's fairly recent, but the spec is a general spec, and Zen has supported the generation ID for 10 years, something like that.
Yeah, and the other thing that was mentioned is not designed for long-running sessions. If you have some insight on that, maybe Marek has.
Yeah, this is actually a question for Andrew. Because the VM forking is implemented specifically for fuzzing, and the
No, it was implemented for something else, and Tamas used it for forking.
yeah, but the thing is, I've from what I've seen on the description of the feature, it works only for a couple of hundred of instructions until specifically the device emulator is not started at all, and also I think PV devices are not connected and stuff like that.
Some of those were Tamas not necessarily cutting a few corners. It's not actually that bad.
Okay, yeah, so we did snapshots before and a long time ago, and we needed to do quite a lot of custom ugly hacks like editing VM memory directly to like replace host name and stuff like that, change IP addresses, and that was ugly.
Well, that was exactly why VM forking was put in originally. It was a startup called Cloudflock, something like that, Snowflock, something like that. And the entire point was exactly this kind of problem, but with Windows VMs. For large VDI solutions, when all your employees log in at 9 o'clock in the morning, suddenly you need to make several thousand VMs in 0 seconds. And the current solution for that involves preloading them from about 3 a.m. and people don't like that. It was a startup. They got a whole bunch of code upstream into Zen and unfortunately folded. So what we have in Zen for VM forking is the result of that, which is a half-complete feature. It's got a lot of potential, but needs a little bit of fixing.
I see. Thanks.
I have a question. So thank you for this work. Amazing, I would say. Maybe have you looked at on how we could accelerate starting of VM? I think it's more a question for the guys on my left. What I have in mind is basically the behavior of a micro VM, or what you could do with Firecracker, like starting VM in like few milliseconds. So I don't know if you have looked at this problem, or
In a few milliseconds, I don't know.
on how we can do that on Zen.
You can answer.
Yeah, I would ask Val. I don't know how to do that on Zen, but she found some way to start a KVM VM in like 100 milliseconds or something like that, up to the getting a shell.
Yeah.
So that was quite impressive. Well, under a second, up to getting a shell. in the
Okay,
VM.
awesome.
So, yeah.
It's not what Val did. It's much more simpler, which is what the user can do. It's like using a less bloated Linux kernel and faster. But it's just some things that I wrote that did not fit. But yeah, it's not super imaginative. But yeah, there's that.
Okay, thank you.
Thank you.
Thank you.